Please welcome back to the stage your moderator, Chief Sustainability Officer for GM, Kristen Siemen, Founder and CEO Redwood Materials, JB Straubel, and Vice President Battery Cell and Pack for GM, Kelty.
Okay, well, I can honestly say it feels much better to sit on this side and be asking the questions versus answering them. But I am honored to be on stage with both of you. I mean, the incredible, again, as an engineer, maybe I might, get a little deeper, but incredible honor to be here today with JB and Kurt. So if we could start, from what I know, you've worked together in the past. So love to hear a little bit about you and maybe what you did in the past.
Sure.
You
want me to dive in here?
Yeah.
My name is JB Straubel. So today I'm the CEO and founder at Redwood Materials. We do battery recycling and battery material manufacturing, but I spent most of my career at Tesla before this, and was the CTO there for 16 years and really deeply involved in battery strategy and powertrain strategy. And Kurt and I had the pleasure of working really very, very closely there for a lot of years, right in the heart of that battery ecosystem, helping define how the batteries worked, where we got them from, and what they were made of.
Awesome.
And I'm Kurt Kelty. I head up our battery cell and pack team at GM. I've been with GM only about 6 or 7 months now, so I'm still relatively new there. Before that, as you just heard, worked at Tesla for many years, 11 years. I think I'm the only one that worked there that long with one boss. So JB and I worked very closely together. He was a co-founder, so I remember when interviewing, I think you were 25 or so. He was still so young, but I recognize brilliance. That's one thing I do have a good eye for, and it was like, well, I want to work with these guys. I want to work with JB, and so we had we traveled the world together. The big thing I was working on was finding battery cells, and JB helped me with that. We did a lot of traveling together through mainly Asia at that point. Yeah, it was a lot of time we spent together.
Awesome. I can only imagine the stories of what was talked about in those rooms and the technology at the time. So thank you. So in my role, one of the questions that I get often asked is about battery recycling, and can they really be recycled, and what happens at the end of life, and the whole question revolving around, are we really doing something better? So maybe I'll throw it out to both of you and get your perspectives.
Well, definitely one of the big concerns about EVs, I think, that's been out there since the beginning is about that end of life. Are the batteries kind of creating some hazardous legacy? And there's really an interesting fact, which is that the metals inside of the batteries can be reused again and again. Inside a lithium-ion battery, nothing is actually consumed. All you're doing is charging and discharging it and kind of shuffling internal to the battery from one side to the other. But we can reuse all of those metals, all the lithium, the nickel, the cobalt, and copper, really infinitely. As far as we can tell, there's no degradation when you re-refine and use those again. So it's very different than plastics or paper, where the recycled one is kind of brown and maybe not quite as desirable. With metals, it's different. And with metals, you're able to refine it again and manufacture it back into a new battery with indistinguishable performance to the first one. So that was part of what got me so excited to found Redwood Materials years ago, was realizing that this kind of vision for the future, where once we electrify the vehicle fleet and once we convert it the first time, we won't have to mine very much material at all to keep maintaining that fleet and to building the second generation and the third and the fourth of EVs.
Super exciting.
Yeah, and we're doing it already. I mean, this is something that it's not something you just do in the lab. I mean, even today, we've partnered together, and Redwood is taking all the scraps from our facilities, from our battery manufacturing facilities, and recycling them. So it's already being done today. And JB and I have a long history with this. We set this up at Tesla, recycling there. Boy, it was probably, 2008 or 9 or something when we started recycling Tesla Roadster battery packs. And the industry's come a long way. I mean, back then it was using a sledgehammer to the problem.
Literally.
We'd freeze them with liquid nitrogen, and then we'd break it down to modules and freeze them, and then we'd throw them in a shredder, and it would just, it's like taking a sledgehammer to it. And then we use filters to filter it out. Now, the process now is quite a bit different, I think, than
Somehow I have
set
this
up.
vision of young kids, tearing things apart and trying to rebuild them together. So sounds fantastic. So Kurt, maybe I'll stick with you. As we try and continue and accelerate this journey at General Motors, how does this partnership help us from a battery standpoint, both from an economies of scale and really as we look at how it impacts our product development, et cetera?
Yeah, so right now we're in the very early stages, and the reason for that is the volume is just really small in EVs today compared to what it's going to be in about 10 years. And so we're starting with all the scrap metal that comes off of our battery cell manufacturing, and at the same time we're also recycling all the battery packs that come back from the market. So we're getting some old volt packs and bolt packs, and we're working with Redwood on that as well, and some other companies where they take the packs and they'll recycle it. Now, we're kind of just setting the stage for what it's going to be in the future, trying to learn how this works. There's a lot to set up in this. I mean, one of the biggest things, one of the biggest challenges we have is how do you arrange for a battery pack to get back from the market to the recycler? And these are things we're working on right now. Because there's safety concerns, there's hazardous material concerns, and so you can't just put it on a semi-truck heading off to one central location. We've got to figure out how to do that in a thoughtful way. And so we're at the early stages of setting those deals up, but that's a real challenge for us. And the opportunity we have right now is the volume's small enough we can get our hands around and start to work with the logistics providers that are going to help us with this.
Great. I mean, so JB, as Kurt said, we're early stages, long way to go, I'm sure, and as this EV market continues to scale. But can you maybe talk a little bit about Redwood, what you've accomplished so far from a sustainability, impact standpoint, whether it be with Ultium cells or just overall, what this is really going to mean to us?
Yeah, it's pretty amazing, the integrating impact already of doing recycling, and it's grown faster perhaps than maybe I expected it would. This year at Redwood, we'll probably recycle on the order of 20 gigawatt hours of material, equivalent battery material. And obviously the industry is bigger than that, but the recycling process is so dramatically more efficient and clean than mining that it already is making a sort of a dent in the CO2 emissions and the water consumption. Recycling is perhaps around 80%, less CO2 emissions per kilowatt hour or per battery produced with it. And we blend that material that we recycle back into the battery supply chain. So every time we recycle, 1 kilogram of battery material or battery, that's 1 less kilogram that doesn't have to get mined, that didn't have to get refined, and it reduces dramatically that impact.
And if I can just add on to what JB said is 20 gigawatt hours worth of materials that are being recycled now. Just to put that in perspective, at GM, we're the largest producer of lithium-ion cells in the US right now, and our first plant was 40 gigawatt hours. Our second one was ramping up to that as well. So 20 gigawatt hours is a lot. And I mean, your growth rate is tremendous right now, so I can imagine a couple years, we could be able to meet all of the US manufacturing needs for that.
I mean, that's the vision, really, is to be able to reduce the emissions of making a battery and making an EV so that the emissions payback is even faster, and it really just completely removes that concern about is the battery a toxic problem at end of life? It's actually a resource that we should all be really excited about, that we want to hang on to. Absolutely,
and I thoroughly appreciate you both making my job a lot easier. So that'll answer all the questions or naysayers that are out there. So as we think about Redwood being a leader in the battery recycling space, GM being a leader in both, as you mentioned, Kurt, battery cell manufacturing and EV manufacturing, where do you see this helping to accelerate this transition maybe or changing what we're going to do in the future?
You want to take?
Well, I mean, to me, the big thing is that ideally, the costs are going to come down if you can recycle the materials. It should be cheaper than the virgin material. So that's a direction we think it's going to go. The other thing is we'll be less reliant upon overseas suppliers. I mean, the nickel right now comes from mainly in Indonesia. Philippines, places like that where they're doing a lot of mining there. And so we should be able to reduce that, which is a big environmental help to be able to do that. The other thing is it's going to reduce our emissions over time. So we get less emissions from battery packs, which is fabulous. And that's the biggest driver of emissions in EVs is the battery pack. And so if we can reduce that, that's another tremendous advantage I mean, you got to think about it. Some of the things that are being talked about right now is deep sea mining.
Right.
That's another approach that's being thought of to get metals because we can't get enough nickel and copper and the other metals that are needed. But do we really need to go to that point? It would be really helpful if we can avoid doing that by just recycling. And we're on that path right now. We just need to get more volume, and then we can recycle more.
Excellent.
Well, I think well said. I would really agree with the cost point of view. More than half the cost of a battery today is in the materials inside of it, just the commodities and the metals. And we can fundamentally reduce that cost dependency by having higher and higher recycled content. So I think over time, as that content goes up each year, that can be kind of a hidden cost reduction trend for batteries that benefits everyone. Because obviously, we need cheaper batteries, we need cheaper EVs for further adoption. So to me, that's one of the reasons I'm passionate about this particular area, because it feels like a hidden way to really support the whole electrification movement.
For sure.
Maybe the other piece just on the mining and accessibility, obviously it's very hard to permit new mines, whether it's in the deep sea or whether it's in the US. And that delay and the lag and the controversy, some of it warranted on permitting new mines, I think is the counterpoint to also recycling, where we're actually, somewhat alleviating that need for mining. We're actually only the second operating lithium provider inside the United States today, and it's all recycled. Know that.
Congratulations.
So it's interesting that can start to happen faster and via this different pathway.
Yeah, to put a new mine in operation takes roughly 10 years. When you think of the permit process and getting it all the way into production, it's roughly a 10-year period. So recycling is going to be a lot faster than that. And then the other thing is a huge cost. I mean, to do one big hole is about $1 billion for mining. So yeah, again, recycling has a lot of advantages: lower capex, faster turnaround.
Excellent. What's the biggest challenge, maybe from an actual recycling standpoint? And then, Kurt, I'd love to hear your perspective from a design standpoint. What do we need to think about? So maybe.
Yeah, I think Kurt touched on it before, but logistics, packaging, aggregating these materials from the field wherever they might be found, whether it's dealerships or whether it's with customers if they were smaller devices, that is a big challenge. We're investing a lot of our time and effort. A big part of our company focuses on that logistics problem. Most people don't think of it, and it's just you focus only on the process of recycling, but.
Right.
A lot of the cost and complexity is in that movement, and doing it safely. There's a lot of rules and unique things that have to be considered with moving a lithium-ion battery. So that's probably one of the challenges that I would focus on.
Yeah, just to emphasize, so logistics is one, and then the other one I touched on earlier was we don't have enough volume for the industry yet. We need more EVs, and we need them to go to end of life. I don't want them to go prematurely end of life, but you need to drive a lot and get them in the market. The other thing, as JB and I were talking right beforehand, is we need to expedite the validation process. So of cathode materials. For example, what Redwood's going to one of their product is a cathode material, and what they need to do is convince the cell manufacturer to change their cathode supplier. And that's a big deal, and it requires a lot of validation, and you really have to push them in this direction to get it across the finish line. So there is work. Unfortunately, even if you make the same identical product, they don't just snap it up like that. They need to be pulled into that arrangement. So I think those are kind of the three big things that I see.
Are there more things that we can do from an OEM perspective, either from a design or manufacturing, that makes recycling easier? Well, how do we build that into our process?
Yeah. There's definitely certain design elements and things like this that are easier to recycle, but the challenge I think is really more about how do we get adoption to happen faster. So
I
while
agree.
it's tempting from a recycler point of view to say, oh, I wish you would just design it for recyclability, please.
Yeah.
You know, I also kind of, you know, have worn previous hats where I remember that, you know, cost, serviceability, and just the consumer adoption is what really matters. So, and also, you know, recycling, we have to address the entire fleet of what's ever been built.
True.
So even if we were to design the perfect thing that was much easier to recycle, that might take 5, 10, 15 years for it to come back in volume. And in the meantime, you know, we have to solve the problem of all the things that have been built. So anyway, it would be wonderful, that would be helpful, but I feel like we don't want to miss the forest for the trees, and really pushing electrification faster, getting more EVs of any type, of any design on the road is what I would be championing.
Excellent.
So I think, yeah, we definitely see eye to eye on that. That's what we're all here for. The one other thing I want to point out is I want to try and prevent the battery packs from getting to the recycling facility in the first place. That's
Fair.
And the way to do that is to design in a way that enables repair, remanufacturing, servicing of the pack. So, for example, the metal top and bottom case of the battery pack, to make that in a way that you can actually open it. Right now, it's designed in a way, but I think all the manufacturers do this in a way that the seal is super strong because you don't want moisture getting in there. You can't have anything get in there. And so how can you design it so you can open it easily? So that's one thing. A second thing is, how can you design it so you can change, let's say, one battery cell? If you have one cell that fails, right now, you dispose of the module, because that's the smallest replaceable unit. But could you design it so that you could just swap out a cell? So that's ways to prolong the usefulness of that battery pack. And then the other thing is, ideally, we get battery packs that'll even last quite a bit longer. And there's technologies under development now that'll get, instead of 1,000 cycles. 1,000 cycles is kind of typical for 150 or 200,000 mile range vehicle. But you can imagine if you have chemistries that'll get you to 2,000, 3,000, 4,000 cycles, you can actually use it for a much longer period of time, and you can actually open up other applications for it, like vehicle to grid or something like that. So there's things that we're looking at the OEM side to prolong the useful life of the battery, and also potential other applications for it.
Great. So you talked a little bit, JB, about, you know, the fact that there's different chemistries out there, different OEMs. How do you drive or have those conversations? Is there forums? You know, I always talk about the sustainability space being extremely collaborative. We work across industries, we work with other OEM partners, et cetera. Is the same thing happening in this space? Or how can we maybe help it?
It is. I mean, there's a lot of collaboration, and I think one of the benefits we have is being almost a little bit of a Switzerland, so to speak, where we can, you know, work with a lot of different OEMs and a lot of different chemistries. You know, and aggregate that to get to higher volume, and that gives an economy of scale that everyone benefits from. It's a little bit harder if you have very, you know, siloed activities. So this is a case where, you know, it's part of why, you know, we don't make cells, because we didn't want to overlap and compete with some of our customers and partners. We wanted to have a scope that was, you know, sort of broadly helpful and where collaboration could be done a little bit more safely, and people weren't worried about, you know, losing secrets to one side or another. But we really do need that scale that Kurt was talking about. You know, that we're still in this, you know, ramp up and learning phase where, as, you know, more products, you know, come in to be recycled, and as the scale increases, the costs are dropping fast, and the efficiencies, you know, continuing to climb.
Absolutely. And I know maybe both of you, as we look at, we have a lot of focus. Clearly, we're an American company, and our biggest market is in the U.S., but we're a global company that operates in many different regions and sells vehicles across the globe. What complexities does that drive into what we're trying to accomplish here from a circularity standpoint as well?
Well, I'd say an interesting part of recycling is it's kind of fundamentally regional. You know, it's difficult to take material from one region and ship it all the way to another. It's too expensive to ship and sometimes hazardous. So it really forces a regional look at that supply chain and that closed loop, which is beneficial in some ways, because you really, I think, want to tighten up these supply chains.
Sure.
But it also means we have to then, you know, operate in a lot of different regions, just like you do. You know, we're already operating in recycling in Europe. In Germany, we have a small facility. But it's chicken and egg. As the EV markets move and grow in certain places, so too do all the other supporting pieces of that ecosystem.
Yeah, we've had to add in. So we're having the U.S. Take the lead with recycling with GM, but we've got regions around the world, of course, that have to deal with the same thing. And so we've got regular calls with them as they kind of ramp up their operations, whether it's in South America or Europe or Asia. We've got to set this up locally, as JB has pointed out. We can't send everything back to Detroit and then reuse it that way.
Yeah. Absolutely. What about from a battery technology standpoint? You talked a little bit about, being able to open the battery up or replace one cell. I'm sure there's lots of control systems, et cetera, that we're developing along that. Anything else from a battery technology standpoint that you see that's either going to help or be a challenge to really drive this circularity as much as we want it to, be successful?
I'll take that firstly.
Yeah,
I think the biggest impact will be with LFP. Iron phosphate is a chemistry that's really the leading chemistry in China right now. Probably 80 or 90% of the vehicles use iron phosphate. And I bring that up as a challenge because there's not much value in the materials there. So the incentive is not as great to recycle that. Nickel batteries, which is what we predominantly use in the States here, there's a lot of value in the nickel, the cobalt, the aluminum that's in those battery cells. So you don't need to incentivize the OEMs to recycle that. We're going to get money. We look at battery packs, that's dollar signs on that. With LFP, it's a different story. You can recycle it effectively, but the logistics costs are a lot of money. And so you got to figure out, okay, how can we balance this out so that it actually makes sense to recycle the LFP. So that's a technology that is coming to the U.S. We're good. GM has announced that we are going to use LFP in the future. So it is a technology that's coming, and our competitors are doing that as well. And so we've got to figure out, okay, how are we going to set up the recycling chain for a chemistry that's less valuable?
Anything to add?
No, I think that's a good one to highlight, actually. And we recycle LFP today and high nickel. We kind of have to blend and address all these things. And there's really no feasibility to just throw an EV battery pack in a landfill. That isn't happening. It's not going to happen.
Thank you.
So, it's hazardous if nothing else. And that really does set up the mandate, though, to figure out how do we most cost efficiently recover everything that we can from whatever the different chemistries are. And there's good customer reasons why people want LFP. It provides a lot of value. It also still has a lot of lithium. It has copper. It has aluminum. It has many other valuable elements in there. So it's not zero, but it is a little bit more challenging, and we just have to be a bit more creative and do some good work.
Excellent, excellent. What about, I know before the panel that I was on, and that we had some of the government affairs and talking a little bit more about government relations is, how it interfaces in this space. From a battery perspective, I know we've got the battery passport that's out there. What else maybe is a challenge or an opportunity to work with regulators to help advance this space?
Yeah, we were actually just talking about that beforehand. I mean, in general, I think leaving it to the free market is the best solution here in the sense that there's value to these battery packs, and we're all incentivized to recycle them because, as I say, we see dollar signs on these battery packs. So I don't think the government needs to do anything to require making money. We'll do that. We can take care of that part. I do think that there are some opportunities to accelerate the adoption of using materials coming out of Redwood. There are potential. You could put a % requirement for recycled material, for example, on new batteries that are being purchased. There's things like that that could be done.
Okay.
Yeah, I think maybe two things I would highlight. One is reusing materials is fundamentally a local resource. So if you kind of zoom away from it, it's really exactly the same as mining, and we don't have very many sources of some of these critical materials in the country or even within the kind of broader friendly free trade countries. So I'd say really kind of understanding that and having the government help highlight that and and promote it to whatever degree we want to have secure supplies of these critical materials, that I think we should look at it just the same as a new nickel mine or a new lithium mine or something to that effect. And the other one I would really agree is on promoting recycled content. Mm-hmm. And one of the levers to that might be with emissions. Because recycled materials have such a dramatically lower amount of emissions associated with them, maybe there's a pathway to have the government set some emission standards for the making of the batteries, or the making of, indirectly the making of the car itself. Because if governments are incentivizing EVs, generally under the goal of reducing emissions of cars and transportation, I think it should matter, what are the relative emissions that made that EV? The goal of the product is to reduce emissions, so I think we should start to think a bit more critically about how many tons of CO2 does it take to make one battery pack or a car or a cathode material.
I know Kurt's thinking about it.
Yep. Yeah, I know you guys are leading the way on this.
Excellent. Well, thank you. So you both mentioned, and I know you're both extremely passionate about this EV transition, and certainly we're here on transportation focus, and that's where my passion is right, how can we accelerate this? Any thoughts that you would give as to how to make this happen faster, or maybe a word to those in the audience that aren't driving an EV of how great it is, or your perspective? How do we sell them? How do we sell the world?
Yeah, well, I think, so at GM, what we're trying to do is give enough vehicle choices out there. So we've got 9 EVs on the market right now. By the end of the year, I think we'll have a dozen. And we're hitting pretty much every market segment. And I think that's really key to get the adoption rate up, is to have an option in each market segment and to drive that price down so that it is competitive and it's compelling. I think that's the biggest thing we can do as a producer. And then the other thing is, as far as selling it, I think we just need to get people in EVs. Because once you get in it and you actually bring one home for a day or a week, you really realize the benefit of it. It's just such a the experience.
It's a better experience.
It's a much better experience, and so I think those are I mean, for us as a manufacturer, we just got to drive costs down and performance up and get lots of varieties out there.
Yeah, I mean, I would say really helping people understand the cost of ownership benefit. It's such a huge benefit, and it's sometimes I feel like I'm going crazy when people that it's hard for them to make a logical choice on it. EVs are by far the lowest cost per mile to operate and lowest cost of ownership, and it doesn't get included, I think, enough in the pricing. The other one is perhaps just, as an industry and as an ecosystem, keeping a really clear focus on charging infrastructure. At Tesla, I spent a huge amount of time on this. We really focused on that. I think there's now a lot of other companies kind of focused only on charging ecosystems, but it's complicated. And I believe that's one barrier that we're kind of running into as an industry as we get into a whole new wave of customers that maybe don't want to have 5 apps open, and they don't want to have a spreadsheet to plan a trip or something like that. We need to make that very easy, very accessible, not at all scary, seamless. Yeah.
Fantastic. Well, again, thank you very much for taking time out of, I know, what's incredibly crazy schedules to be here. Thank you for what you're doing, and both of you are making an incredible difference on this industry and our future. So I really appreciate it.
Well, thanks for having us.
Thank you.